I'd like to talk to you about some exceptions to the octet rule when it comes to drawing Lewis structures, and a concept known as formal charges to build up to understanding what is the best Lewis structure. So, in a previous video, we discussed how the octet rule and the duet rule for hydrogen are the go-to principles when deciding how to rearrange electrons around atoms in Lewis structures. So remember, the octet rule implies that there should be 8 electrons around each atom for stability. Now, there are some important exceptions. Some small atoms cannot accommodate 8 electrons. So as an example, I've shown here boron hydride. Boron has 3 electrons, around 3 valence electrons, and therefore it can only form 3 bonds with hydrogen. So boron at its peak would have 6 electrons surrounding it, rather than 8. Now let's move on to the concept of formal charges. The Lewis structure model involves localized electrons. In other words, electrons are located solely in a specific atom or shared between specific atoms. For polyatomic ions, the charge must also be localized. To determine where the charge is localized, one must work out a formal charge for every atom. A formal charge is a comparison of how many electrons an atom had as a free atom to how many electrons the atom essentially has after becoming a part of a molecule. Now, to demonstrate this, I'll draw the Lewis structure for CO3 carbonate. So this would be the Lewis structure for CO3 Now, this is a polyatomic anion, therefore we need to indicate where the negative charge is coming from. Now, to do this, we need to figure out the formal charges. Now, what we do is we simply determine the number of electrons that an atom effectively has to itself alone in the molecule, add up all unshared electrons in lone pairs and half of all shared electrons in bonds. Compare this to the number of valence electrons the free atom would have when neutral. Look on the periodic table. By looking on the periodic table. Now, the formal charge is negative if the atom has gained electrons by becoming a part of the molecule. The formal charge will be positive if the atom has lost electrons by becoming a part of the molecule. So, in our example here, let's take this. Let's take the bottom left oxygen as an example. Now, if we count just how many electrons are around oxygen itself, we would count 1, 2, 3, 4, 5, 6 electrons, which oxygen alone possesses. And remember, for bonds, we have the number of electrons involved in the bonds. So it would be 1 more here. That is 7 electrons in total. Remember, oxygen has a grand total of 6 valence electrons. So the difference here is by 1, and oxygen has gained 1 electron by becoming a part of this complex. So we indicate this by a circled negative sign on both oxygen atoms because they are both in the same disposition. So now I'd like to finish off by talking about what the best Lewis structure is. Now, sometimes it's possible to draw more than one Lewis structure for a molecule or a polyatomic ion, even if the rules are followed. Now, how do we choose which one's the best? Now, generally, let's try to observe the octet rule. Now, this means trying to maximize the number of covalent bonds while minimizing the number of formal charges if possible. Now, these two processes usually go hand in hand. Negative formal charges should be located on more electronegative atoms, if possible, and vice versa for positive formal charges.